This week we have two lessons, one about continental drift and one about space exploration. All right, let's start learning about continental drift. Our goal in this lesson is basically to figure out the evidence that helps support continental drift theory. Some of you guys have learned a little bit about this with Mr. Corcoran, so let's think about what we've learned before on this. This is a quick video that you'll watch, and then there's a little bit about how we know that the Earth isn't quite stable, that there's got to be something moving it, something causing great things like mountains to rise up. I've actually been here to that specific barn. That's the Grand Tetons out in the American West. I recommend that you read this. I'm actually narrated it. So when you click on these speakers, I will read it out loud to you. So I'm going to let you do that on your own so you can follow along. All right. And then there will come to a big interactive. Let's do this interactive together. All right, I'm going to click to start on it, and we're going to see the way that scientists think that the continents on Earth looked all throughout history. There's a few types of ways we can move through this. I can actually press on my keyboard the left and right arrows, and it will take us through time, and you'll see that the surface of the Earth changes. Another way I can take us through time is by clicking this drop-down box here. And I can say, what does it look like 300 million years ago? What does it look like, let's say, 50 million years ago? Ooh, 50 million years ago, it looks similar to today, but we're not connected to South America, and there's an ocean going through it. That's odd. If we look further, 105 million years ago, wow, this ocean here is really skinny. So you can use the arrow keys to move both ways. You can actually click and drag around the Earth to try to see where we are. And then we can say, well, what was life like with the first dinosaurs? What was the Earth like then? And you can click on that. Ooh, so maybe we had Pangea back then. Looks like the continents are connected. What was it like when we had the first hominids, so the first early humans? Ooh, it looked pretty similar to today, actually. All right, that was only 20 million years ago. I see that up top. So have fun with this interactive. And to answer those questions that follow this, please make sure you come back up and try to find the answers. All right, first question that you're going to do, though, you're going to write down kind of what you saw. What does it make you think about? And what does it make you wonder? Some questions that you have. Question 2, when did the supercontinent Pangea exist? So how long ago was that? So you're going to have to go and find that. Number 3, what first appeared on Earth 120 million years ago? So go back and click 120 million years ago, or try the things on the right-hand side until you see what happened 120 million years ago. Number 4, use the Jump To menu in the interactive to find out when the first land plants and the first primates appeared. Primates are things like chimpanzees, gorillas, humans. And how many millions of years were there between those two events? You've got to do some subtraction once you find out those two dates. Number 5, you've got to find 2 facts of your own that you like from that interactive. All right, let's move ahead. This guy, his name is Alfred Wegener. Even though his name starts with a W, it's pronounced like a V. Alfred Wegener. He was a brilliant scientist. He actually died while trekking across the ice, and it was so cold that basically his research group buried him in the ice where he is to this day. Alfred Wegener noticed that he thought a lot of things happened. He thought the continent shapes lined up like they used to fit together like pieces of a puzzle. He noticed fossils that can't swim across the ocean that are in different continents. How are they in different continents if they couldn't swim? He thinks they were maybe once together. And so he came up with this idea that the continents move. But nobody believed him. Well, some people did, but a lot of people said, you don't have enough evidence. But over time, the evidence has come through, and it's proven that he was right about this. You're going to find some of that evidence later on, and we'll talk about even more evidence next week. So you'll read about Alfred Wegener and watch a video about him. Let's look at these questions. You can take notes about the video there. Number 7, according to the video, which of the pieces of evidence did Alfred Wegener use to support continental drift theory? There's going to be more than one answer to this question, so read carefully. If you forget, go back up and do some reading and watch the video again. Number 8, select 2 statements that help explain why scientists didn't accept Wegener's theory of continental drift. Why didn't they believe him? So there's 2 right answers to that one. All right, now we're getting into something that's going to take us into a really cool interactive. Pangea was actually formed from 2 smaller supercontinents, one that was basically Asia, Europe, North America. We were part of that. That's called Laurasia. And then another one that was called Gondwana, or Gondwanaland. That was the rest of the world. And those were together as Pangea. They split up into these places. And the 4 kinds of fossils that we look at, as you see, we've got something that looks almost like a lizard or a mammal here. This is Synognathus. These are hard to pronounce. He's definitely not a swimmer. This is Glossopteris. This is a tree, obviously. This is Mesosaurus. He's a swimmer, but I think they're more like alligators than they are like whales. So alligators can't swim across oceans. And this is Lystrosaurus here. So none of these guys could swim across an ocean. So next you're going to come across an interactive that you get to see if you can figure out Gondwanaland. So it's made up of South America, Africa, India, Australia, and Antarctica. And your job is to use the places where these fossils were found. We think that those used to match up. And so you're going to see if you can fit the shapes of the continents together and the locations of the fossils. It's a little bit like a puzzle. You need to use all 5 of these shapes. So I'm going to put Africa right here. And let's see, I'm going to start with India. I'm going to pull it over. Oh, it needs to be turned though. And you see this little dot here? That's a handle. If I click on that and I hold it down, I can actually rotate that a little bit. What about that? If I doesn't perfectly fit, but it's been a couple 100 million years since that's happened. So that kind of fits together like this if I just move it around a little bit. Your job is to see if you can fit together all 5 of these. And I gave you a hint of where to get started. Make sure you think about the shape and the locations of the fossils. Once you finish with that, you're going to be answering these questions here. When Africa formed part of Gondwana, which modern continents did it touch? So go back and look at what you found. I know one thing it touched was India based on this. All right, so it might be, it will be more than one answer here. It might not be all of them. So figure out based on the map that you made. Number 11, understand, how did fossil evidence help support Wegener's theory of continental drift? So basically, how does this help support the idea that the continents were once together and that they moved apart since? How does that support that idea? Why does this help prove his theory? You're going to have to write down a sentence or 2 there. Oh. You're watching at YouTube, I apologize for the weird pause here. Okay. Now we're going to look at new evidence that was developed after Wegener died. So we're looking at the bottom of the ocean here, and we think that it's moving, and we have evidence for that. We actually used submarines during World War II to map the ocean floor, and we noticed huge mountain ranges. You read about it over here, or you can have me read about it to you. And we found out sea spreading. There's actually this line of mountains down the center of the ocean between North America and Europe, between South America and Africa. It's a middle ocean ridge. And what's happening is you've got a lot of new material coming, forming new ocean crust, and that's making the sides of the floor move apart. And if they move, then maybe that carries along the continent. I don't know. So let's answer these questions here. Number 12, which of the following did scientists discover on the ocean floor? All right, you might have more than one answer there, but it might just be one. I don't know. Number 13, consider the history of continental theory. What does this tell you about the nature of scientific theory? So think about it isn't just a rule that scientists say never be broken. There are things that over time, the things that we try to build more because all theories are supportive of evidence. All right, let's continue going here. Basically, all you have left is this reflection, and I think that should look familiar to you. It's the same cell phone one where he's trying to summarize a point. Don't just give a couple words here, give us a sentence summary, okay? Don't forget to do lesson 2 this week, which is all about space exploration. I love it. I'm really excited about it. All right, take care, guys. Mm.